Welcome to the deep dive. Today, we're tackling a topic that's, well, it seems kind of invisible, but it's actually everywhere. Microplastics.
That's right. They're turning up from the deepest oceans to, well, potentially inside us. It raises some pretty big questions.
Absolutely. And you shared a really insightful scientific review, Microplásticos en el cuerpo humano. Our goal today is to, pull out the key stuff.
Exactly. What they are, where they come from, why we should care.
Right. Without getting bogged down in super heavy science jargon, we want everyone to get the picture quickly.
Sounds good.
So let's just start right there. What exactly are microplastics and why should we be paying attention?
Okay, good starting point. So microplastics are essentially tiny pieces of plastic. And when we say tiny, the sort of scientific consensus is particles smaller than 5 millimeters in diameter.
5 millimeters, like a sesame seed.
Roughly, yeah. And it goes down from there, down to 1 micrometer. That's incredibly small, 1,000 times smaller.
Wow.
And anything smaller than that, smaller than 1 micrometer, we actually call nanoplastics.
Nanoplastics, okay.
And it's important to remember, a lot of these tiny bits actually come from bigger plastic things breaking down. Bags, bottles, what scientists sometimes call mega, macro, or mesoplastics.
So big stuff fragments into tiny stuff. Makes sense. I mean, you see plastic litter breaking up.
Precisely. That's a huge part of why they're so widespread and persistent.
Okay, so the review you sent over splits them into 2 main types, right? Primary and secondary. Let's talk about primary first. What are those?
Right, primary microplastics. These are, they're interesting because they're actually made small on purpose for specific uses.
Made small? Like what?
Think about microbeads. Those little plastic spheres?
Yeah.
They used to be common in face washes, exfoliants, even some toothpastes.
Oh, right. I remember those.
Those are primary microplastics. They're also used in some paints. And as the little plastic pellets, they call them nurdles sometimes, that factories melt down to make bigger plastic items.
Okay.
And the review mentioned they're sometimes used because they're cheaper than, say, natural ingredients in cosmetics.
So designed tiny from the get-go. It feels a bit weird, doesn't it, given all the talk about reducing plastic?
It does seem counterintuitive in some ways.
And you mentioned medical uses, too. That wasn't something I'd immediately connect with microplastic.
Yeah, it's less obvious, but it's there. The review gives the example of a drug called Asacol. It's for ulcerative colitis.
Okay.
Researchers found phthalates. Those are chemical additives often used in plastics in the pills coating. It's an enteric coating.
Enteric coating. What's that for?
It's designed so the pill doesn't dissolve in your stomach acid straight away. It releases the medicine lower down in the intestines where it's needed.
Ah, I see. So the plastic components are actually functional in that case.
Exactly. They help control the drug delivery. So it's not always just waste. Sometimes it's part of the design.
That's fascinating. Okay, so primary microplastics. Deliberately small for cosmetics, industry, even medicine. Now, what about the other type? Secondary microplastics. This seems more linked to the plastic waste problem we hear about.
That's absolutely right. Secondary microplastics are the breakdown products of those larger plastic items.
Mm-hmm.
The bottles, bags, packaging, fishing nets, all that stuff we see polluting the environment.
And how does that breakdown happen? Just wear and tear?
It's a mix of things. The review really highlights photodegradation. That's sunlight, the UV rays, attacking the plastic structure.
Makes it brittle.
Exactly. Makes it brittle, cracks it, breaks it into smaller pieces. Then you've got mechanical forces. Think about waves pounding plastic on a beach, or wind action,
right,
or just abrasion, plastic rubbing against sand or rocks in rivers or the sea.
Okay.
And there's even some biodegradation where microbes like bacteria and fungi can slowly break down certain plastics, though honestly, for most common plastics, that's a very slow process.
So mostly sun and physical forces just grinding it down over time. The review also mentioned some maybe less obvious sources of these secondary ones.
Yes, definitely. One huge one that might surprise people is synthetic fibers from washing our clothes.
From laundry, really?
Yeah. The numbers are pretty startling. The review cites figures suggesting a single wash cycle could release over 1,900 microplastic fibers.
Per wash. Wow.
Yeah, into the wastewater. And think about how many washes happen every day globally. It's massive.
Yeah.
The review also notes that even just handling plastic packaging can cause tiny bits to rub off through abrasion.
Huh. Never thought of that.
And another really significant one, often overlooked, is tire wear.
Car tires?
Absolutely. As tires roll on the road, they constantly shed tiny particles. It's a mix of synthetic rubber and other materials, essentially microplastics.
I had no idea.
The amount depends on things like the road surface, temperature, how fast you drive, the tire itself, but it adds up. Estimates run into thousands of tons of microplastics from tire wear every year. It's a major source.
Thousands of tons just from tires. That's incredible. What about more conventional waste streams?
Well, wastewater treatment plants are a big factor. They're designed to clean water, obviously, but they often can't filter out all these microscopic plastic particles.
So some get through.
Yes, quite a bit can get released into rivers and eventually the ocean. Then there's general urban waste, stuff that escapes collection systems, landfills where plastic slowly degrades.
Right.
Industrial sites, maybe spills of those plastic pellets we mentioned earlier, and even incinerating plastic waste can release particles if it's not done perfectly.
Okay, so it really feels like the sources are just everywhere, linked to so many parts of modern life.
That's the reality. They originate from countless points in our production, consumption, and disposal cycles.
Let's just quickly recap then. Microplastics, smaller than 5 millimeters, down to micrometers, even nanometers.
Nanoplastics. Yeah.
They're either made small on purpose, primary ones in cosmetics, maybe medicine, or they come from bigger plastics, breaking down secondary ones from litter, washing clothes, even driving our cars.
That sums it up well.
And they're getting into the environment through a whole load of different routes.
A huge number of pathways, yes. Which, as the review points out right at the start, really sets the scene for why this is such a growing environmental concern.
Definitely. Okay, when we come back, let's talk about where these things actually end up and what the potential risks are. Not just for the environment, but, well, for us too. Stick around.
Sounds good.
Welcome back to the deep dive. We've established what microplastics are and the many ways they're generated. Now, the big questions. Where are they going and what harm could they be doing? The review you shared paints a, frankly, pretty concerning picture.
It really does. I think the main takeaway is just how ubiquitous they are. They're not just in one place. They've basically infiltrated every environmental sphere you can think of.
Everywhere.
Pretty much. The review mentions them from the deepest ocean trenches.
Wow.
To Arctic sea ice, which is supposed to be pristine, right? To the air we're breathing right now. And, quite disturbingly, the food we eat and the water we drink.
It's hard to wrap your head around that scale. The review also used this phrase, microplastics acting as a cocktail of contaminants. What's that about?
Yeah, that's a really crucial point. See, these little plastic particles, because of their chemical nature and large surface area for their size, they tend to attract and bind other pollutants from the surrounding environment.
Like magnets.
Sort of, yeah. They absorb them onto their surface. The review mentions specific things like phthalates, those additives, again, flame retardants, heavy metals like lead, copper, cadmium, even bacteria and viruses, potentially harmful pathogens.
So the plastic itself might be one problem, but it's also carrying other nasty stuff with it.
Exactly. That's the Trojan horse idea the review talks about. An organism swallows or inhales a bit of plastic, but it's also getting a concentrated dose of whatever toxins have stuck to that plastic.
That's a really potent image, the Trojan horse.
And interestingly, the review notes that things like UV exposure from sunlight can actually change the plastic surface and make it better at absorbing some heavy metals. Yep. So degradation might make them more dangerous in that sense.
Okay, so if these plastics, potentially loaded with toxins, get into living things, what damage can they do? What are the risks?
Well, there are several levels. First, just the physical presence. If an animal eats enough plastic, it can cause blockages, internal injuries, or just make them feel full when they haven't actually eaten nutritious food.
False satiety, right.
Exactly.
Yeah.
That can lead to starvation. It can reduce their mobility, mess with digestion. But beyond the physical stuff, there's the chemical risk.
From the plastic itself or the stuff stuck to it?
Both, potentially. Yeah. There's concern that these absorbed toxins can leach off the plastic once inside an organism and get into tissues or the bloodstream. And also, the plastic itself isn't always inert. The basic building blocks of plastics, the monomers, some of those can be toxic on their own. The review mentions styrene, for example, from polystyrene.
Styrofoam, yeah.
Right. Styrene is considered a potential carcinogen. And if you ingest polystyrene, could that styrene monomer be released inside you? That's a concern.
And the review had a table, didn't it? Listing potential issues.
Yes, table 2. It links various monomers to a pretty worrying list. Potential links to cancer, neurotoxicity, reproductive problems, acidosis, breathing issues, skin problems like dermatitis, asthma. It's quite a range of potential health effects associated with the basic chemicals used to make plastics.
That is, yeah, that's sobering. So where has the science actually found these microplastics? Let's tick through the environments. Water bodies first.
Okay, water. Definitely. Oceans, rivers, lakes, groundwater. They're pretty much confirmed everywhere water is studied. and glaciers too.
Glaciers!
Probably deposited from the atmosphere over time and then trapped in the ice. The scary part the review highlights is, as glaciers melt with climate change, they could release this stored-up load of microplastics into the ocean.
Wow, a ticking time bomb almost.
In a way, yeah. And they're found in really remote places like the Arctic, and deep-sea plankton have been found with plastic inside them. Urban wastewater, as we mentioned, consistently shows high levels, and washing machines are a known major contributor to that.
Okay, so water's definitely full of them. What about the air? You mentioned breathing them in.
Yes, atmospheric transport is real. They've been detected in the air, in cities, suburbs, but also in remote areas far from obvious sources.
So they travel long distances on the wind.
It seems so, which means they can then fall out of the air, deposition, onto land and water, pretty much anywhere. The review cites studies measuring how much plastic dust is falling in cities like London and Paris, and it's not insignificant.
Falling out of the sky. Okay. What about the ground? Soil and sediments.
They accumulate there too. In rivers and the deep sea, they sink and become part of the sediment layers. It's like creating a geological record of our plastic pollution.
A plastic layer in the future rock record.
Potentially, yeah. And in soils, especially agricultural soils, they can come from things like sewage sludge used as fertilizer.
Because wastewater plants don't get it all out.
Right. And also from plastic mulch films used in farming, or even from some types of polymer-coated fertilizers designed to release nutrients slowly. The review notes that the types of fibers found in sediments often match what's coming out of wastewater plants.
So a clear link there.
And interestingly, some studies show concentrations might be higher in the upper layers of sediment, suggesting maybe this really widespread pollution is a more recent thing, historically speaking.
That makes sense. Okay, water, air, soil. What about life itself, the biosphere?
Well, that's where it gets really worrying for ecosystems. The review states microplastics have been found ingested by a huge range of organisms. We're talking everything from tiny plankton.
The base of the food web.
Exactly.
Yeah.
Up through fish, shellfish, birds, marine mammals, amphibians, even creatures living miles down in the deep sea.
And if they're eating it?
Then you get those physical problems we talked about, the false fullness, but also the potential for bioaccumulation and biomagnification.
Explain those quickly.
Bioaccumulation is when toxins build up in one organism over its life. Biomagnification is when those toxins become more concentrated as you go up the food. The food chain predators eat prey that have accumulated toxins, so the predator gets an even higher dose.
So it gets worse higher up the chain.
Potentially,
Yeah.
yes. It could have really serious impacts on top predators and entire food webs.
Right. And what about us, humans? What does the review say about microplastics in our bodies?
It outlines the main ways we're likely exposed. Inhalation is one, breathing in fibers and dust. Ingestion is probably the big one, through food and water.
Yeah.
And maybe some skin contact, though that's less clear.
Ingestion. So we're eating and drinking this stuff.
The evidence points that way. The review mentions that standard water filters often aren't designed to catch particles this small. And significantly, studies have detected microplastics in human poo.
So it's definitely going in. Is it staying in?
That's the billion-dollar question. Some likely passes through, but there's real concern, especially with the nanoplastics, the really tiny ones, that they might be small enough to pass through the gut lining into our tissues or bloodstream.
And what would happen then?
We don't fully know, but the concern is they could trigger inflammation or immune responses. The estimates for how much we inject annually are quite high, numbers like tens of thousands or even hundreds of thousands of particles per year.
That many.
Depending on diet and lifestyle, yeah. And interestingly, the review notes bottled water often seems to contain more microplastics than tap water.
Really? You'd think it would be cleaner.
Maybe from the bottle itself or the bottling process. It's not entirely clear why. Plus, the review links inhaled fibers to potential lung issues and mentions the known link between some textile dyes, which might be on fibers, and skin irritation.
It really feels like exposure is unavoidable. And the review specifically listed foods where they've been found.
Oh, yeah. It's quite a list. Things you might expect, like seafood, fish, shellfish.
Yeah.
But also table salt, beer, honey, sugar.
Beer and honey? How?
Maybe from airborne deposition, filtering processes. It's not always obvious. Also tea bags. Some plastic ones shed fibers into the hot water. Drinking water, milk, soft drinks, wine, even chicken and packaged meats.
Packaged meats?
Yeah, the example given is meat packed on those polystyrene trays. Tiny bits of the tray can apparently embed in the meat surface, or hard to wash off, and then get cooked and eaten.
So it's infiltrating the food chain at pretty much every level?
It seems that way, yes.
Yeah.
From production to packaging to processing.
Okay. The review also zoomed in a bit on South America. What's the picture there? Is it different?
Well, it points out that while the region might produce less plastic waste overall compared to, say, Asia or North America, some specific South American countries actually have quite high per-person contributions of plastic getting into rivers.
Which ones?
Guyana, Venezuela, Uruguay were mentioned as having notably high levels of riverine plastic input per capita. But there's also a growing amount of research happening across the continent.
Where are they studying it?
Countries like Peru, Brazil, Argentina, Chile, Uruguay, Colombia, Ecuador, they're looking in rivers, coastal areas, and different animals. So awareness and research effort are definitely increasing.
That's good.
But a key point the review makes is the need for more standardized methods. Right now, different studies might measure things differently, which makes it hard to compare results across the region or track changes over time.
So need to get everyone on the same page method-wise.
Exactly, for better comparability and reliability of the data. The review also notes there's still basically no published data from some countries, like Bolivia, Venezuela, Paraguay, the Guianas, so still big gaps in the map.
Right. So growing research, but still patchy and needs standardization, kind of mirrors the global picture, maybe?
I think that's fair to say. We're learning more all the time, but there's still a huge amount we don't know about the full extent and the long-term effects.
Well, this has been incredibly eye-opening and a bit unsettling, honestly. Microplastics are clearly not just some niche environmental issue.
No, absolutely not. Their sheer presence everywhere, and this ability to potentially carry other toxins. It really does make you stop and think.
It certainly does. So as we wrap up this deep dive, maybe a final thought for everyone listening. When you consider how unavoidable these tiny plastic particles seem to be in the air, water, food, potentially inside us, and their Trojan horse potential, what are the really long-term consequences going to be?
That is the critical question, isn't it? For planetary health, for ecosystems, and for our own health and well-being.
It definitely makes you reconsider maybe our own relationship with plastic, our consumption habits, and the huge societal challenge of dealing with all this waste. Perhaps this conversation is a starting point to look more into the ongoing research, the debates, and what potential solutions might be out there for this really complex and clearly growing global problem.
Let's hope so.
Thank you for joining us on the Deep Dive.